So let's take a look at the volume of a triangular prism. And whether it's a triangular prism or a rectangular prism, it's still the same idea. If we can find area and we can slice it so that every slice has the same area. So if I slice it like this, every one of these slices will have the same area. So if we can do that, then we can still use our area times thickness formula. So if I take a look at this, that red space here represents a triangular area, and that triangular area will show up in every slice as I give it some thickness in this direction. Okay? So the area of the base of this then is going to be that triangle, which is going to be 2 times 5 divided by 2. So we get 5 centimeter squares. Okay, so if I were to imagine this, there's 5 squares that fill up that space. When I talk about the height of the prism, really I'm talking about the thickness, so maybe I'll change this to thickness. Okay, that's the same thing. It's going to be the thickness of that prism, and the thickness of this prism is 4 centimeters. So if I want to find the volume, I take the volume is equal to the area of the base, this area, times the thickness. Okay. In this case, the thickness is 4 centimeters. So the volume that I'm going to get is going to be 5 centimeters squared. And I'm going to multiply it by the thickness of 4 centimeters. And that's going to give me a volume of 20, and the centimeters squared times centimeters is going to give me centimeters cubed. So the volume of this triangular prism is 20 centimeters cubed. Now, it would have been perfectly okay to find this volume by using length times width times height. And that would give us a rectangular block. Okay, and we want exactly half of it, and then divide it by 2. It's perfectly okay to do that, and you'll get the same answer, but we want to make sure that we understand volume in general is area times thickness. So if I did this here, 2 times 5 times 4, that gives me a volume of 40, and then I divide that by 2, I'm going to get a volume of 20 centimeters cubed, which is perfectly fine. That's exactly what I got here. And it's perfectly okay to use this. However, make sure you understand this general idea. Area times thickness gives us the volume. If I take a look at this next example here, we have Jake's family. It opens a full carton of ice cream for dessert. And if you imagine a carton of ice cream that you buy at like maybe Safeway, it comes in a rectangular box. It kind of looks like that. And after they eat, there's 3/4 left. So I'm just going to maybe slice this into 3/4 here. So 3/4 are left. Okay, we'll say that this is like, this is lemon something flavored. So that's what's left. So what volume ice cream did this family eat? Okay, so basically we have our 18 across here. It's going to be 9 high and 12 wide. Okay, actually we don't know exactly. Let's just do it like that. Yeah, we'll say that's 9 by 12 by 18 like this, and they ate that portion of it. Okay, so what we could do is we can find out the entire volume and divide it by, well, there's only 1/4 left, so we can do 18 times 12 times 9 centimeters. Okay, and then that will give us the total volume. Okay, length times width times height, and that gives us a total volume, which is 18 times 12 times 9. Let me just work that out. 18 times 12 times 9. That gives me 1944 centimeters cubed, and I only want 1/4 of it, so I could just divide by 4, and I get 486, which is perfectly correct, and that's centimeters cubed. I could also look at this from a different perspective. I can take the area of one side. I can take that area. So I'm going to take the area is equal to 9 times 12. And that would give me 108 centimeters squares. And then I can multiply it by the thickness. So this thickness here is 1/4 of 18. If I divide 18 by 4, I get 4.5 centimeters. So if I take the volume is equal to the area, 108 centimeters squares, and I multiply it by the thickness, 4.5 centimeters, I'm going to get the exact same answer I got before. 108 times 4.5 is equal to 486 centimeter cubed. Okay, so we can use that method, area times thickness, or we can do length times width times height, and get this exact same result. Okay, but it's important for us to start visualizing volume as area with thickness, and that's going to give us our volume.